it hardly takes 100 MB of space in your device. You just have to download the software from internet and you have to create your account, and that is it. You are good to go. That is it, nothing else. And just because it is cloud based, that is why you just need a good internet connection. And if you have that, it will run as fast and as smooth that no other software can match also. Okay. And also it prevents the sudden software crashes or app crashes, which might occur when you are doing any sort of calculation in other software or designing anything. So here, I hope you all can see the screen here. So what is happening here? So there is an offset plane, and there is a video going on the loop where, and what is happening? There is a circle. Then that circle comes to a 3D object. Then there comes a rectangle, and then that rectangle also comes in an 3D object. So what is happening here? So basically, we are trying to make a mounting here. So what is it? It is a mounting for the roll cage of a vehicle, where you are, for example, you are designing a roll cage for the vehicle, inside roll cage that I'm talking about. So if you're designing that, so in that mounting, you can put the bars of the roll cage, and you can place it with the chassis. So this is what the mounting looks like in the roll cage of the vehicle. We'll be seeing this in the real time also. This is just here for the reference only. What we'll be seeing in the later part of the session. Coming to our second topic, which is drawing or drafting. So Fusion 360 has this feature where what you can do is whatever you are sketching, okay, so your sketch can completely automatically turn into a drawing, okay, which will have the ability, which will have isometric views, top view, side view, front view, back view, all the views you will having. Other than that, you will be having dimensions and labels also, so which makes it clear. For example, if you have to give your design to a worker or machine operator, for example a lathe operator, so you'll have to make him understand the dimensions. Other than that, if you can provide him this drafting, he'll be able to understand it, and he'll be able to make your product or component very precisely, because this will give the precise direction to the machine operator. As you can see, I have mentioned the advantages also. First is clear dimensions, obviously we can see. Then we have easy to understand, then easy to feed to the machine. So if the dimensions and labels will be clear, so feed to the machine will be clear only. There will be no confusion. And accurate machining process. And obviously, if the feed is right, the machining process will definitely be accurate. And all this process can be done with one click only. There is possibility that if you want something additionally customized, that you can do as well. Other than that, if you want everything to get done automatically, that is there also. Coming to the next part, which is simulation. So in Fusion 360, we can carry out different sort of simulations. As you can see on the screen, these are some type of simulations that we can carry out. So we have static stress, modal frequency, electronic cooling, thermal stress. All these kind of simulation analysis we can carry out in Fusion 360. So here you can see on the screen that the mounting that we were talking about earlier. So I have done a static deformity stress analysis on the same mounting. So as you can see, the actual the actual picture of the mounting. So you can see there is an outline on top of the circle. So that was the actual shape, and the material of the mounting is actually compressed. So that shows the deformity from when the load is applied on top and the base part is constrained with the load constraints, then the deformity, then we are seeing that where exactly the load is getting applied and where we will be getting the resultant force. So where we are getting the deformity, where uh, the chances of breakage or maybe leakage or getting a crack, where is that, what is the exact place. So we get this analysis done in Fusion only, and that is how we do the deformity test. Other than that, we have got static stress, which is in the deformity test also comes under static stress only. Okay, then we have modal frequencies. So what are modal frequencies here? So for example, when you have designed a component, and you have to make sure that the component is going through enough vibrations, noise, and harshness. So we have like three component, which is called NVH: noise, vibration, and harshness. So when you want to make your product or component compliance with NVH, so you have to get done this analysis, which is modal frequency, where different sort of frequencies, different sort of vibrations will be provided to the design component, and then it'll be analyzed that what sort of result we are getting from all those vibrations, and how much the noise we are getting, and how much the harshness we are getting from that component. So that is modal frequency. Then we have electronic cooling. So Fusion 360 also offers us to design PCB. Okay, PCB boards. We can design PCB boards in Fusion 360, and obviously when we are designing PCB boards, and there are a lot of electrical and electronic components there. So PCB boards generally get very heated while they are in operations. So we can perform electronic cooling analysis there also. That how can we make it? How can we dissipate the heat? How can we design it in a way where we can dissipate the maximum heat and keep the temperature in the limited amount. Then we have thermal stress. I hope you all know about it. Then we have
Excuse me, sir. Presentation screen does not to be show, sir.
it is not visible.
Yes, sir. Presenting screen does not to be show, sir.
Okay, just a
Fusion
second.
360 presenting screen.
Just a
Yes, sir.
second.
Is it visible, Sandeep? You can leave and again join.
Okay, sir. I will try.
Yeah, it is visible. I hope it is visible now. Yeah, moving on to the quasi-static event simulation. So what is quasi-static event simulation? Quasi-static is nothing but basically when you are applying load on a particular component, but in a defined set of period, that is time. So for example, you are applying 100 kilonewton of force on a component in 10 to 15 minutes or maybe in 20 minutes, and then you are checking out the deformity, the integrity of the component that you have created. uh, I would request whosoever is opened their mic, please turn it off. Okay, so moving on from simulations, we have come to the part where we can show what is rendering here. So render in Fusion, what is render here? So design or models made in Fusion need to have a physical appearance, as well as they how they would look in real life conditions. This is where render helps with providing a lot of options. For example, that we have taken an example of that same mounting here, that how would this mounting look in real life we have to figure out, because currently it looks very vector like a form, like a cartoonish sort of a thing. But we need to understand that how it would look when it comes to life in a physical form. So in the picture you can see in the top there is a panel, control panel. Let me just tell you what are the things there. So as you can see, the first object, the first uh, symbol we have, which is appearance. And in appearance, then we have scene settings, then we have decal, then we have texture map control. So what all these are? So the uh, these are basically the operations that we can do when we are rendering it, when we are rendering the component that we have created. So in appearance, as you can see, we have got material selection and paint selection. So you have created a component. Now that component should be made out of aluminium, or you say, for example, it should be made out of stainless steel or any alloy, or it can be made out of wood or plastic, PLA, PETG, ABS, any sort of material. All these material libraries are already present in Fusion, so you don't have to go and get any other library. Yes, if there is some alloy that are there that are not there, you can definitely download that from the official website of Fusion 360. Other than that, you will get a wide range of material library. Then we have decals, where you can put your custom graphics or custom creatives on the same, like embossing anything on the, like if you're designing a product, sorry, not a product, but if you're designing a mounting, or let's say a product, you can write down your name on it. You can put your company creatives on it, and you can see how it would look in the real life conditions. Then there is texture map control. So what does it do? It basically, first, obviously, it controls the texture of the map. Then it controls the texture projection. And what is map here? That I'll tell you. In the scene setting, what is scene setting? So in scene settings, we have environment selection and we have light selection. And in environment selection, we have a lot of things, lot of different kind of environments. We have like an environment where there is a complete skylight and uh, trees, and we have a ground and everything. So one is that. Other than that, we have a studio setup where you can see 3-point light. So one is coming from the top, one is coming from the side, and other is coming from the other side. So environment like these are already there in the library. So you will get like plenty of environment. Even if you want something to be something customized, you can customize your own environment, as well as you can get it download from the official website. And the for example, when you have applied any environment to the scene, then you are able to control the texture of the environment, also the texture projection, how you want that texture to be projected. And what by texture, what we mean, for example, you want a sky. So you have to define the texture of the sky, how bright it should be, or what sort of which shade of blue there should be, and there should be clouds. So what sort of clouds, like what should be the intensity of the cloud should be. So all those things can be done in texture control. Moving on to the animation part. So this is like the final part of the introduction to Fusion. So what is animation? I hope everybody knows what is animation. When something is moving, and like it's a set of pictures that is recorded, and it is moving also. Okay, so Fusion provides a very dynamic experience with animation. It allows you to create a complete motion with as low as 1 second time interval. So you can create animations from as low as 1 second to 10 seconds to 15, and to later on how much you want to go. everything you can do in Fusion. So as you can see, there is a control panel on top, and there is a timeline on the bottom. And in middle, in the middle part of the screen, you will see that your the design component will be there, and you can choose how to animate it. You can rotate it, you can move it, you can disintegrate it. As we can see in this particular design, this whole design is counted as one body. So with this design, we are not able to disintegrate it, but we will. I'll make you see how the disintegrated uh, looks in animation. So moving on, let's see some example of animation here. So as the video is moving here, you can see so there was some sort of movement that I did, and I recorded in the timeline. If you can see, I have marked the cursor to 5 seconds, and I am moving it. And when I am moving it, it is actually recording in the real time. Okay, so when it is recording, now the recording is completed, and I can play it in the real time only. So it is very easy to animate anything in Fusion. Okay, so coming on to the design process, what is the design process? How you should design, on what are the parameters that you should look before designing? So, like the very first step should be you should know what you are designing. You should have a create and clear picture inside your head, what you want and how it should look. Secondly, you have to set parameters for the design. For example, if you are creating a coffee mug, so you should know that what should be the diameter of the coffee mug and what should be the thickness of the walls and everything. Okay. Then third part will be start drafting the 2D image first. Obviously, you will be drafting the 2D image only, and then you will move on to 3D. Okay. Then if you are making an object which has different components, for example, if you are designing something to vehicle related, or if you talk about electric vehicles, so if you're designing a battery pack, okay, so in battery packs there will be a range of batteries, okay, and other than that there will be other components. For example, the box will be there, the structure will be there, and everything will be there. So you'll be designing all these things separately first, and then you will be joining everything together. So that is where it says connect all the bodies together to form a complete one component. Okay, and as soon as you are joining them, you also have to assign the joints and fixtures. So joints and fixtures, what they do. So for example, let the same example that we took, the battery pack. So the battery pack should not move while the vehicle is moving, right? It should be stationary at one place where it has been appointed as. So the base of the battery pack should be there, should be fixed to one point. Okay, so even if anything is happening to the design, it should not move. And in the same case, when we are designing for say uh, differential gearbox or differential gears, other than that, if you are designing a steering column or anything, so in that part it should move. So you have to assign the joints and fixtures like that. And there are many options of joints and fixtures. We'll get to know about it in some time only. Then we come to assigning the material and paint, then render to see it in the real world conditions, obviously that we have just did. And then later on, if there is some errors, so you have to fix those errors. And in the last part is export your design, or just do, just if you want to uh, 3D print it, you can 3D print it, or otherwise you can just export it. So here is some part of the designing process. Actually, let's move on from here. I'll be showing it this designing process in the real time only on the Fusion 360 software. So you can see on the screen there is a differential gear design process. As you can see, like every gear is coming one by one, and I have designed it like the way it should be. So you see this is the top view of the design, how it is looking. This is the side view, this is the front view. Like you can see all the gears are perfectly meshing with each other, right? So this is the kind of accuracy you can get in Fusion 360. And also this picture seems to be very complicated, but is actually not if you know how to use it Fusion 360 in a smarter way, because there are a lot of things, there are a lot of tools that are there which makes it very easy. And as I was telling you that this is how an animation looks like when we are actually moving it in a real time condition and real world condition. So let me just play the video once again. Just a second. Here, so you see the whole gear, the planetary gear and all the bevel gears are actually meshing it. And when one is moving to the one side, you see there is another gear which is connected to it, which is moving to the other side, which is actually demonstrating how a differential works, right? In a different speed. So from here, we'll be directly moving towards the software part of it. Let's move towards it. Let's see how Fusion 360 looks like. So I hope my screen is visible to everybody. So as you can see, this is the interface that we were talking about. See that I've already showed you this interface, that you'll be getting this kind of interface where we will be having, this is the control panel that we were actually talking about. And here in the top left corner, you see this part, this is design. So when you click on it, you see different uh, options here. So one is design, then we have generative design, then we have rendering that we have already talked about, then we have simulation, animation, simulation, manufacture, and drawing. So all these aspects are there. You can easily choose any of these and do whatever you want to do. Okay, so let's suppose taking this same mounting only, and we have to for say we have to make a drawing of it. So here you can see two options, drawing from design or drawing from animation. So we'll go with design only, okay, because from animation it would take some more time to understand and learn how to go from animation, but we'll start with from design. So if we click here, so it takes some time. So you see a dialog here, a dialog window comes here, and you can see two options. One is automatic. Okay, so you have to click on automatic if you want to uh, generate your drawing automatically, and you don't want to do anything. Okay, just put automatic here. And also you have to describe the sheet size. Generally the sheet size is A3, but it is up to you. You want a custom sheet size or A3, A2, A1, A4, whatever. Okay, and Also, you have to set the units. I have set the units in mm. You can choose according to your need. You can choose in inches or mm both. Then standards. So we have ASME standards and ISO standards, and so these all the things that you can choose from here, and then you have to hit OK. Okay, now you see there is a loading icon coming on. That means it is preparing the picture. It is preparing the drawing that we want in the back end. Okay, so you see this dialog comes here. It says view job status. You click on it, and here you will see the real time progress of your design. So right now it is getting designed. So it probably, yeah, it is almost, yeah, it started only. So also let me tell you, this process might take some time. It totally depends on the design to design, like how many components are there in the design, and how many joints and fixtures are there. So see, it says it is complete, and we can open it from right here. It is getting opened. Here you can see. So uh, on the right dialog box, you can see there is a streaming that is happening. Here you can see different dimensions and different isometric views. So we have like you can see here we have 33 iterations of the same design that we have just created. So we have 33 iteration of that same design. So that is why it takes some time to calibrate and control to calculate everything. And we just minimize it from here, and you can see we have the complete design of the mounting that we created here. You see your name and everything will be here. Other than that, your this is the top view, this is the side view, this is the other side, sorry, this is the front view, this is the top view. So or everything is here. And also if you want to modify anything, you can do anything from this control panel above. So you can change the dimensions, you can add your dimensions, you can add labels, symbols, you can add, if you want to add picture, you can add a picture. If you want to add tables, you can add tables here. So almost every function that you would be requiring is available here. Okay, so this is how you create your drawing or drafting. Okay, so let's come back from this process, and let me take you to the very basic and first process, where how you sketch, how you draw anything, or how you uh, get into Fusion 360. So first of all, in the top left right corner, you can see uh, there is a cuboid which says top view, front view, right view. So every view is there like this. So top view is this, then we have, this is the front view, then we have right view. So all this kind of views are there, and we have to select a plane, on which plane you will be making your design. Okay, so we'll come here in create sketch, and we'll see the options here. So we are getting 3 planes, so we'll be choosing this one. Okay, and as soon as you select your plane, you see the control panel is changed now. Okay, so you have got, so in create you have option of creating line, rectangle, circle, arc, polygon, ellipse, slot, spline, point, text, mirror, circular pattern. These many options you have here in create. Then in modify you have fillet, chamfer, blend curve, offset, trim, if you have to trim something, extend, break. So these kind of options are there. And then we have constraints. Constraints mean if you are designing, for example, you are adding two, like you are connecting two circles through their tangents. So you can create a tangent and you have to constrain that tangent so that even if when you are extruding it, it should not move anywhere. Okay. So, or you can create, make them equal. You can create a tangent. You can coincide them. You can make parallel lines, perpendicular it. So a lot of constraints are there. Okay, so let's start with let's make a simple cylinder here. So what for cylinder, for to make a simple cylinder, what we have to do is you have to click on create, come on circle, and come on center diameter circle. Okay, you come to the center or wherever the point you want to, and click, and you just drag it. Now you see there's a dialog which is coming there which says centimeter. So it is your diameter of the circle. So you can specify what diameter you want. So for example, let me take 8 centimeters here. So and enter. So you see I have created a circle here of 8 centimeter diameter. Okay. So this has been created. Now this is the sketch, and how I should turn it into an object, how it should turn into a circle. So what you have to do, so as I am moving my cursor on it, you see it is getting lighten up. So you have to take your cursor and you have to click. You see it has glowed. You can see this blue light, and from there right click, and you will see press pull option there. Okay, so you click on the press pull option and you see an arrow here. Okay, and you just take the arrow upwards. Okay, or if you don't want to take the arrow upwards, if you want precise dimensions, so give dimensions here. So let's suppose we are giving it 6 centimeters. So as soon as we give the dimensions here, it will create a body. Okay, and you okay it from here. So from a circle we have created this cylinder. You can see it is a 3D object. We have created a cylinder. Now what if we want to have another circle, or if we want to see through this circle, like this is a solid circle or solid cylinder, let's have a hollow cylinder. So what we can do, again, you just click, know that we want to see that this should be hollow. So we want a circle or hole from here, this place. So you choose it. Okay, you select it, and then you go to sketch, and then select again circle, center point, and just choose how much the diameter you want. So let's say I'm taking 6 only. Okay, so I have created another circle here, and again I'll be selecting this and right click, press pull. Okay, now as I'll press pull, earlier we went up, but this time we will go downwards. So when we'll go downwards, it will create a cut. It will create a cut through the body. Okay, and okay from here. So as soon as we did okay, you see this cylinder is hollow now. Okay. Then same, for example, you have to this cylinder is working like a spacer in between the wheels. So like when we are putting wheels in an automobile vehicle. So this is working like a spacer where you are actually uh, taking wheels a little outer side of the from the vehicle. So okay, so then we would be requiring some sort of threading here, because obviously the screw, the nut, the lug nut which is there in the vehicles will get fasten in. Okay, so if we'll if we'll use it just like this, it will stay there, but it will move because it is a very plain structure. So to make it more rigid, to make it there only, to keep it there only, we can add threading here. So how we can add threading here? So first of all, what we can do is we have to select this inside area, okay, and we have to come here, create, and then as soon as we come to create, you come down and you will see this option thread. Okay, so you click on thread, you see it has already created some threads there, and it is up to you like how big threads you want. Okay, so you see I can just play with the dimensions here like this way only. Okay, and also there in this dialog you can see you can also decide the direction of the thread. So by default it is on the right hand side thread, but you can also keep it as left hand side thread. So in many manufacturing processes there are threads which are actually the other way around. Okay, so you can see you can choose left hand or right hand, whatever your requirement is, and you okay it. As soon as you okay it, now we can see we have like complete threading inside, right? So this is how we can create anything from sketching to a complete body. So this will counted as one single body. Okay, so by this method you can create anything. You just need to make sure that you are desiring whatever you want, and you are defining the parameters. So let's move on to something on an advanced level. So let me show you one. So what we were actually looking at in the presentation, a bevel gear system, or we can say a differential system here. So you see there are like what we have created here is a set of 1 2 3 4 5 6 gears. Okay, so 6 different components we have created here. Okay, so as you can see, all the components are here. Okay, so how I managed to create these? So there are two options. First is obviously uh, you can sketch it from the scratch, just the way we did it. Like we created that cylinder, we can definitely sketch this complete gear assembly from the scratch. Also, just to make it easier, Fusion offers libraries, okay, from where you can get all these. So there are two methods. First is you come to the utility, then you come to the add-ons, add-ins. Then you see scripts and add-ins. So you click on it. Here you will see the pre-customized library of Fusion. Okay, so we have appearance to selection, apply material to selection. Then we have a bolt, we have a bottle, then we have a customer graphic sample. Okay, we have a pipe, and here you see we have a script of spur gear. Okay, so what we can do is you just click on it and then run. And here in the dialog, you see the dimensions of that spur gear. So from here you can see the pressure angle. Let it be 20 degree only. This is the default. The module. Okay. What should be the module of it? Okay. The number of teeth you can get, for example, 24 only. Then root fillet radius. Consider it 0 right now. Gear thickness, how thick it should be. Let's say 5. Hole diameter, the diameter, how much it should be. Let's say 5 as well. And pitch diameter, it will automatically generate here. Okay. And from there, you just have to press OK. Okay. Just a second. Once again. Oh, okay. The module we are using is wrong. Okay, something is wrong here. Just a second, let me just restart it. Okay, just a second, everyone. So this is how you can add the gears assembly here. Other than that, we'll come back to the solid, and here you can see insert. Okay, so for example, you have to create anything for automotive vehicles. Okay, so here in insert dialog, you can see this insert mech master car components. So it's a preloaded library which is already there in the Fusion. So you have to click on it. It takes some time. So you see, you have like a whole load of components here that are already there, preloaded. Okay, so we have screws, we have bolts, helical threads, anchors, nuts. So, and here you can see electrical and lighting components, then fabricating, fastening and joining, hand tools, hardware. So same, we can search here gears, gear. Okay, so you see gears and racks. So what sort of gear you want? So for example, if you are uh, designing a steering assembly, so you would be requiring a gear with a rack, because we in that we use rack and pinion. Okay, so here some sort of arrangement like this you can uh, put. Then we have like other than that, we have bevel gears here that we have already used. So see this sort of gears we have used in our project only, in our designing. So what you can do is you can directly come here, select anyone. Okay, you come down, and from here you have to select which is your which gear should be according to your requirement. So we have gear pitch, number of teeth, for shaft angle, pressure angle, and gear pitch diameter. So all the parameters are here. So for example, we need a gear pitch of 16 and number of teeth will be 12. So I click on this, and from here you have to get 3D step 3D steps project file, and from there you have to directly download it. So once it is downloaded, you will see it will automatically exported here. Okay, you see our gear is here, so you can move that gear in any way, in any direction and everything, and you can hold it and place it anywhere. And that is how I have made this whole arrangement. I have placed it on top of each other in a way where they mesh together, and then we have created an animation where they are actually moving together. Okay, so that is what you can do. This is how you can add gears, and other than gears we can add more components as well. So at this point I think we are done with the session today, and this is pretty much it for the Fusion 360 session. I am open to questions, so please everyone, if you have any questions you can ask me.
Yes, sir. This is Professor Vartraj Singh. Whether we can design anything which is not available in the library, or it is limited to the library only?
No, we can definitely design anything and everything. If it is there on library, we can design that. If it is not there in the library, we just have to give the parameters, the right parameters, and we can definitely design it.
Okay. I think very
Yes.
effective tool, this Fusion 360 is for the mechanical engineers. Thank you for
Yes.
such an informative and knowledgeable session with us. Thank you.
Pleasure, sir. Pleasure.
Thank you, sir. Thank you, sir.
Anybody else who have any question?
Excuse me, sir. Hello, sir.
Yes,
Hello.
yes.
Excuse me, sir. Sir,
Yes.
how is the basic difference of in which, sir, Fusion 60 will be used to compare to NX?
So basically, in Fusion, so first of all, the basic difference is obviously that we are doing. It is cloud based only. Okay, and
Yes, sir.
you can get done a lot of things in Fusion. Like I have already mentioned, like we can do animation, simulation, rendering, and everything. And in Annex, it is much one
Yes,
type of
sir.
thing operation that you can do there. And in
Yes, sir.
Fusion you can have multiple operations at one point only. So for example, if you take an example of SolidWorks, so you are
Yes, sir.
creating anything in SolidWorks. Okay, for example, you have
Yes.
designed a wheel assembly, or maybe a chassis of a vehicle. So you have to carry out the simulation for it, and you have to take it to the NSYS, and then you have to
Yes, sir.
select the
Deformation
appearance of it.
analysis on. Yes, sir.
Yeah, so if all the process you have to do it again and again. Okay, and you have to create mesh also. But here there is no issue of creating meshes and all. Obviously meshing will be done, some part of the meshing will be done automatically, and some, if the component will be it will be a little difficult, so you also have to do it manually, but not that extent that you do in other softwares. So this is the
Yes,
main
sir.
difference we have. And also,
Hello, sir.
if you
Yes.
are beginner, if you are trying to learn the new softwares, the designing softwares. It is, I would suggest it is one of the best because the user UI is very user friendly.
Yes. Thank you.
Yes.
Hello, sir.
Hello.
Where can I learn the software? Is there any course available on this?
Sorry, your voice is very low.
Where can we learn this software or Autodesk Fusion 360? Is there any course for this?
Courses are there. Other than that, you can download the software from the official website, and you will also find there some basic tutorials.
Any
Okay.
website or Udemy or YouTube? Any website you recommend?
You can go from YouTube only. There are multiple tutorials there on YouTube. And but I would suggest you to go with the Fusion 360 official tutorials, which are there on their Autodesk Fusion 360 website. They provide
And
the yes, yes.
how much time it takes to learn fully all over the concepts of Autodesk 360?
So that
much time
totally
it takes?
depends on you, and it is subjective from person to person. For example, if you are taking this software very seriously, and you are putting 3 to 4 hours daily, so probably it will take you somewhere 3 to 4 months to get to a level where you are able to design and simulate anything you want. But still, there will be some sort of challenges you will always face when you are designing something from the scratch.
And also, where can we use this software other than EV?
You can use this software in any way possible. It is not just limited to the EVs or any vehicles. We can use it in anywhere. For example, the product, if you are going to the industry, like manufacturing industry, if you are going, and that industry is making water bottles. Okay, so
Yes.
those water bottles are also getting designed first, and then they are getting into the real form, right? So
Yes.
there
Small
also the
projects
application
or
is
we
there.
can DIY projects we can design it on.
Yes, 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 definitely. You can design all small, big projects you can design. And also, if you are talking about DIY projects, so there is
Yes,
an
yes.
advantage here. So if you try to learn 3D printing, so what you can do is you can directly design in Fusion, and you can there is an software which is called Ultimaker. You can incorporate that software with Fusion 360, and you can directly print whatever you are designing, and it will come into real life. So that is also there.
Okay, sir. Okay. Thank you, sir. Thank you so much.
Yes. Okay. Okay. Any other question if somebody is having?
Thank you so much, sir.
Thank you,
Thank
sir.
you. Okay, I am handing it over to ISIA India. Thank you everyone for this lovely session.
Thanks sir, for hosting the webinar. Your expertise and insights were valuable for our learners. I would like to take the opportunity to introduce our company, ISI India products and services that we offer in AV technology. That is small video. So kindly have a look on video.
As we are living in the fast-changing world of electric vehicles, ISI India is leading a tech organization, paving the way for innovation and devotionalizing the ecosystem. It is bridging the gap between industry and academia and bringing all the stakeholders to the same table. From 2013, our parent organization has been tirelessly working to create an ecosystem for skill development, research, innovation, and entrepreneurship in the electric vehicle industry. Through CSR skill development and partnership with GIZ, Tata Technologies, Bharat Crop Science, Kalika Industries, Chalna Jan Seva, Masiya, IPCA Laboratories, etc. And with national and international e-mobility events such as Electric Solar Vehicle Championship, Formula Imperial, Indian Karting Race, E-Bike Design Challenge, we have provided a platform for over 3 lakh students from more than 750 colleges and universities to come up with innovative projects. In addition to this, we are offering various skill development programs, faculty development programs, corporate trainings, and spectrum of courses with duration from 9 to 12 months with live and recorded interactive classes, with the added flexibility of paying after course completion. For our contribution towards building sustainable way forward in EV, we have got recognitions such as the National Youth Award from Ministry of Youth Affairs, Government of India, Titans of Technology Award, EDN Star Award from Earth Network USA, and Social Entrepreneurship Award. And we have also joined hands with Automotive Skill Development Council, All India Council for Technical Education, National Skill Development Corporation, Ministry of New and Renewable Energy, and various automotive industries, which validate our global impact and commitment towards excellence. We are now a global partner for talent nurturing in the automotive industry. We are fostering the youths for the global EV market and have recently joined forces with partners in Malaysia, Indonesia, and South Africa. According to the economic survey, in India, the market for electric vehicle is expected to grow really fast, about 49% every year from 2022 to 2030. This means we could see 10 million electric vehicles sold every year, in which led to 50 million direct and indirect jobs by 2030. We are committed to sustainable mobility solutions and our industry-aligned programs cater academia, industry, and government sectors. Our expertise in the industry has led us to design cutting-edge technological solutions for the growing electric vehicle industry. We promote project-based learning, hands-on training, skill development initiatives, vocational training, research, entrepreneurship, public-private partnerships, awareness and outreach programs. Our state-of-the-art facility, the Center of Excellence for Electric Vehicle, is dedicated to spreading the word about electric vehicles by facilitation of technological advanced solutions. EV Tech Lab. It's a high-tech lab designed for students studying engineering, ITI, and polytechnic, students getting job training. Think of it as a space where creativity meets actual hardware solutions. People here get to dive deep into the physical part that make electric vehicle work. This model is also helping our partners for community skilling of various job roles, such as electric vehicle technician, vehicle assembly operator, charging station operator and technician, and workforce for electric vehicle powertrain, battery and BMS maintenance, etc. Second model, that is our Center of Excellence for Electric Vehicle. It's a combination of labs and offering both hardware and software solutions, under which we have established end-to-end solutions for electric and hybrid vehicle design, powertrain, battery and BMS, EV charging, IoT for experimental learning, testing and prototyping. The solution we are providing is unique and help our learners for upskilling, research by getting experimental data and plotting graphs. Our goal is to impart industrial knowledge by establishing pioneering center of excellence. These centers, developed in collaboration with universities, industry partners, and government entities. Our COEs provide integration of EV curriculum in BTech, MTech, and other academia programs. Research and vocational NSQF courses align with the national education policy. Plus, our COEs also support the startup ecosystem by providing facilities for design, prototyping, and product testing. Our labs are making difference. We have established several labs across strategic locations with all kind of stakeholders like industry, Hero MotoCorp, with Government of Kerala in partnership with MG Motors at 2 locations, IIT Mandi, private universities like SRMU, Calcutta University, Sharda University, an NGO with Govardhaniko Village by ISKCON Temple, and various top universities and institutes across India. Our commitment to excellence is unwavering, and by 2025, we aim to establish over 250 plus Center of Excellence worldwide. With India rapidly moving toward an electric-only future, ISA India is well positioned to develop the workforce prepared for the international arena. Join us on this electrifying journey towards a sustainable and innovative future.
Thanks for watching the video patiently. So don't miss out on this opportunity to discover the endless possibilities of reading. So any of you want to enroll in the course, kindly send us an inquiry through a QR code displayed on your screen and take your first step towards a more sustainable and exciting future. Thank you.
Thank you for joining the webinar. I hope everyone has understand the topic. If you have any query regarding the courses, you can scan this QR code. Our executive will contact you shortly. If you are also looking for a courses in Fusion 360, then you can scan this QR code. Our executive will guide you about the courses. Thank you for joining the webinar. If you want to inquire about courses, you can scan this QR code. Our executive will contact you shortly.